Today, I will be discussing about the central limit theorem. What is the central limit theorem? And actually, what is the inner meaning of it? It is very important in statistics. And to have fundamental idea, you should have clear idea over this concept, the central limit theorem. Central limit theorem. Okay, so what is this? Suppose, look, this is a distribution. Suppose this is a distribution. Okay, and this is a population distribution, and you are taking 3 or 4 samples from this population. Suppose you are taking this much here, this sample from this, and you are taking sample from this. You are taking a sample from this region, that is A, and sample B, and here from sample C. So you know the population and the sample. That is, the population has a mean. We do not have the idea of about the mean, but the sample 1 has a mean. Suppose mean is A bar. Sample A has mean A bar. Sample B has mean B bar, and sample C has mean C bar. So you have 3 samples. You have 3 samples and their corresponding means. So now, if you have the mean of these 3 means, that is mean of A plus mean of B plus mean of C divided by 3, then this is the mean of sample means. Sample means. Okay. So mean of samples means should be equal to the population mean. This is the fundamental idea of the central limit theorem. There are 4 theorems. Okay. Look. First, theorem 1. Theorem 1, mean of sample means mean of samples mean is equal with the population mean. Okay, this is the first theorem that I have already proved. Now, the second theorem is, standard deviation of the sample is equal to population standard deviation divided by root n. Okay, the second theorem is the standard deviation of the sample should be equal with the population mean divided by the root of the number of samples. Number of n is nothing but the number of samples. So this is the second theorem, or you can write it this way, that root n multiplied with sample standard deviation equal to population standard deviation. And fourth theorem is that, third theorem, that is if the population distribution is normal, okay, if population distribution is normal, then the sample distribution also be normal. Clear? This is the third theorem. If population distribution is normal, then sample distribution is also normal. Okay. If the population distribution is normal, then sample distribution is also normal. Now, the fourth theorem is, if population distribution is not normal, then sample distribution is also normal. So, if the population distribution is normal, it means it may be exponential, it may be skewed. Okay, so if the distribution is not normal, then also the sample distribution is normal. There is a condition, the number of observations should be greater than 30. That is, n should be greater than 30. Number of sample should be 30. Now, suppose you were with an example. I am going to clarify this. Suppose you are taking 10 watermelons. You are taking 10 watermelons, and the length of those watermelons are, suppose length of watermelon is, you are taking 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And suppose 5 inch, 6 inch, 3 inch and 8 inch, again 2 inch and 8 inch and 6 inch, 4 inch and 9 inch and again 2 inch. So you are taking the watermelons, 10 watermelons and their length. Okay. So now you are taking this, assume that this is the population. And now the true mean, that is the mean of the population, is 5 plus 6 plus 3 plus 8 plus 2 plus 8 plus 6 plus 4 plus 9 plus 2 divided by 10. You know it very well. So 5, 6, 11, 14, 22, 24, 32, 38, 42, and this is 9, 42, 51, 53. Okay, 53. So I am taking here 6, then it will be very easy. 6, so 10, 53, 54 by 10 equal to 5.4. This is the true mean length. The average length of watermelon is 5.4 inch. Okay. So now I am taking samples from here. Suppose I am taking samples, this sample 2, with 2 watermelon I am taking the sample. So 6 plus 6 divided by 2, mean of this sample, and again I am taking 6 plus 3 by 2. Again I am taking samples 3 plus 8 by 2 and 8 plus 2 by 2 and 6 plus 4 by 2. So 1, 2, 3, 4, 5. I have taken 5 samples and their corresponding means. These are the mean. Okay. So this S1, S2, S3 and S4 is 5. Okay, so this is the mean of the 5 samples, and so the mean of this first sample is 6 plus 6 12 is 6. Okay, and 6 plus 3 9 divided by 2, it will be 4.5, and 8 11 5.5, and it is 10 5, it is 10 5. So now you are taking the mean of the means, sample means. So 6 plus 4.5 plus 5.5 plus 5 plus 5 divided by 5. So 6, 5.5, 6, 10, 10, 15, 16, 16 and 10, 16 and 26. So equal to 26 by 5, equal to 26 by 5, 5.2, 5.2. So 5.2 is the mean of the sample means. Now you look, the true mean is 5.4 and mean of the sample mean is 5.2. So if you do not have any understanding, so 5.4 is the true mean, and 5.4 is the true mean, and sample mean is 5.2. Without knowing the population mean, you can have an idea about the population on the basis of the sample mean. So this is the idea of the central limit theorem. Thank you for enjoying this lecture.